All right, hi there, folks. Welcome back to another day of pre-calculus. We're going to continue with our work in trig equations and identities. Today is going to be about solving trig equations, particularly with the use of calculators. All right, before we get into it, though, you've got a few warm-ups to do here. So evaluate each of these expressions in radians. And then number two, given theta, can you determine the reference angle? Remember that notation, theta bar. And then solve the equation cosine of theta is equal to negative root 3 over 2, given that theta is in the first positive rotation. All right, so go ahead and just take a minute and try these problems out on your own. All right, and we're back with some answers. So it's time to check your work here. For number one, we've got pi over 6 and pi over 2. Number three, remember that the reference angle is the acute angle that is measured between the terminal ray of an angle and the x-axis. All right, so we've got 30 degrees, pi over 4, and pi over 3 going across the page. And then remember that we've got two solutions here for those equations. So cosine of theta equal to negative root 3 over 2 has two solutions in 5 pi over 6 and 7 pi over 6. All right, let's push forward now into the meat of what it is that we're going to be doing here. All right, so today's going to be all about the calculator. Here's your first warning. Cuidado, make sure that your calculator is in radian mode and not degree mode. All right, really you want to be basing it in whatever restrictions you're given. So here we are from 0 to 2 pi, meaning that we were in radians. If it was from 0 to 360, you would change it to degrees. But for the most part, these are going to be radians problems. So just, operate in radian mode, all right? But you do want to make sure that you're in the correct mode. All right, so we're going to solve this equation. Sine of theta is equal to 0.32. Now notice that 0.32 is not a normal unit circle value, right? So in order to move forward and get to theta, we're going to have to do some inverse trig. Right? We can see that we have a normal trig function with an input of an angle giving back a radius. So to find the angle that was the original input, we're going to use an inverse function. And this time our output of the ratio became the input for the inverse function. Right, so theta is equal to sine inverse of 0.32. So I am going to hop into the calculator here. All right, let's see how that works out. All right, so first I'm gonna check my mode, because like I said, I wanna make sure that I'm in radians, and it looks like I'm in degrees right now. So I am going to change that. Awesome, we're in radians. And now I'm going to enter that sine inverse of 0.32. So second sine for the blue sine inverse right here, 0.32, hit enter. And it looks like our angle is 0.32573, we'll call it. We'll go to maybe 5 decimal places to start. All right, so let's head back to the notes here. So from our calculator, we just found that theta is equal to 0.32573. Right? And if we're talking about theta inverse with a positive, theta inverse. If we're talking about sine inverse with a positive sine ratio, that means that we're operating in quadrant 1. Right? Because sine inverse is in 1 and 4, but we have a positive sine ratio, quadrant 1. Right? And basically what we just found was this angle. Right? But let's not forget that just as we did in this problem, we have to account for the second solution, right? When we use inverse sine, we're only accounting for half of the unit circle. But for any given sine value or cosine value, there are two locations on the unit circle where that value occurs, right? In the unit circle, if we're talking about this positive y value, that has to be reflected over the y-axis to account for the other angle at which that y value or that sine value occurs. Right? Now, the nice thing about knowing that there's a reflection there is that we have this angle here. It's congruent to our angle that we just found. And hopefully, by labeling it that way, you can see why one of your warm-up problems was to get refamiliarized with reference angles. Right? We want to find the actual angle measure of these two angles that we've drawn on the unit circle. One of them is already given, and we're good to go here. Right? But we need to find the angle measure of this angle. So in order to do that, we're going to use our reference angle and some of the landmarks on the unit circle. Right? We can see that there's 0.32573 radians between our terminal ray and this part of the x-axis. Right? Now we know that that angle measures pi, so if we want to find the measure of this angle theta, we can just do pi minus our reference angle. All right, so I'll go ahead and enter that into the calculator. So pi minus 0.32573 works out to about 2.81586. Right, so the big takeaway here, make sure that you're keeping track of where your reference angles are, and that will help you unlock the answers that you need. All right, so for our two solutions at the end of the problem, what you would write on an answer blank, theta is equal to 0.32572 and 2.81586. All right, just because it's also a common question, I will tell you that these angles are sort of rounded to an arbitrary decimal place. Typically, you will probably get some instructions as to round to the nearest tenth, hundredth, thousandth, but if that's not specified, just sort of use your best judgment. All right, so let's try an example 2, and I might move just a little bit faster here on this one. All right, so sine of alpha is equal to negative 0.65. So that means that alpha can be found by doing sine inverse of negative 0.65. I will go ahead and enter that into my calculator. You find that alpha is equal to 0.7076. All right, so you can come on over to our unit circle here. I'll draw in that angle. So we have negative 0.7076. Right, that means that our reference angle, alpha bar, if you're a fan of Wicked, is 0.7076, right? Positive 0.7076. Don't make the mistake that I almost just did where you just copy down the angle measure. All right. So because we're talking about sine here, we're talking about y values. So we're going to replicate with the angle that gives us the same y value on the unit circle. And we know that this reference angle will also be 0.7076. All right, and at this point, I'm gonna highlight this just so we can tell our angles apart here. All right, now notice that we wanted an angle that was between 0 and 2 pi. So even though we haven't even found the purple one yet, this blue angle also doesn't work for us, right? It's a negative angle, and that's not in the restrictions that we were given. So we're gonna have to do a little more work to find an angle that is coterminal with that blue angle of negative 0.7076, right? In order to do that, we're gonna know that this is the location of 2 pi. And so to find the angle measure of this location of alpha, we can do 2 pi and subtract off our reference angle. So I'll enter that into the calculator. And we get that alpha is approximately 5.5756. Right, we can do a similar thing over here. If we know that this angle is at pi, then we can add our reference angle to pi to find the location of this terminal ray for alpha. So pi plus 0.7076, and we get that alpha is approximately 3.8492. Right, so all in all, when we're talking about alpha here, alpha is equal to 3.8492 and 5.5756. All right, I feel like you're getting the hang of it, but we'll do 2 more here, and this time we're going to pick up on cosine. All right, so cosine of beta is equal to 0.795. Right, that's going to tell us that we can find beta by doing the inverse cosine of 0.795. Just going to approximate to 0.65, we'll call it 2. Again, I'm just sort of terminating my decimals arbitrarily. So, you know, we did 5, we did 4, now we're doing 3. It's kind of your call. All right, so we're talking about cosine, I'm sorry, we're talking about inverse cosine, and we have a positive ratio. That means we are in quadrant 1. We just found that this angle was 0.652. And now if we're talking cosine, right, now we're not reflecting over the y-axis. Now we're reflecting over the x-axis, right? Because we're looking for the spot where we're going to get the same x-coordinate, the same cosine value. Right? That means that we're also going to have a reference angle here of 0.652. Right, now because we're in the first quadrant, our reference angle is equal to the measure of our angle, so that's good to go. In order to find the measure of our purple angle here, our purple beta, within the restrictions of 0 to 2 pi, we'll do what we did above in quadrant 4. We'll do 2 pi minus our reference angle. And that approximates to 5.631. All right. So with that, we have that beta is equal to 0.652 or 5.631. All right, folks, we are very close to the end. We've got one more to get through. Cosine of delta is equal to negative 0.3. I feel like you know what's coming. We can find delta by doing cosine inverse of negative 0.3. All right, gonna put that in my calculator. It's telling me that delta is equal to 1.875. Right, 1.875. So I know because cosine is negative here, we're talking quadrant 2, right? We got an arc cosine with a negative cosine ratio. We are in quadrant 2, right? But the thing that you need to recognize here is that unlike the previous problems that we'd been doing, that 1.875 is not this angle. It's the actual standard angle measure from standard position for our terminal ray here, all right? So really what we've got here is 1.875 from the right-hand portion of the x-axis. All right, what that means is that we need to do just a little more work in order to find our reference angle delta bar. Right, in order to do that, we're going to take pi and subtract off the measure of our angle in blue. So what we're doing here is pi minus 1.875. And it looks like our reference angle delta bar is equal to 1.267. All right, and now we can push forward. We're going to duplicate and reflect over the x-axis because again, we're dealing with cosine. We're looking for the same x-coordinate, the same cosine value. And we know that this reference angle is the same as above. All right, so in order to find the measure of our delta in purple in quadrant 3, we can take pi and add on our reference angle, which we just found to be 1.267. And that's going to give us 4.408. All right, so our two solutions for delta are 1.875 and 4.408. All right, so you've got 4 more problems to try out down here. So go ahead and try those out. These are going to be linked up with the Go formative for today. So you can enter those answers and get some feedback when you're good to go. Otherwise, that is it for today. Have a good one.